This is our part 2 of our lesson about solving systems using elimination. Our objective in this lesson is to solve systems by adding and subtracting to eliminate a variable. This is our vocabulary for this lesson. Pause the video and write this information down. You need to be familiar with what elimination is, the elimination method, and what equivalent means. Alright, now we're going to solve a system. But instead of just being able to add or subtract the two equations together, we are first going to have to multiply one equation by something before we can add or subtract. So here is our system, and we're going to begin by multiplying the second equation by 2. When you add those two equations together, this will eliminate the variable y. So when we multiply the second equation by 2, our negative 4 times 2 gives us a negative 8. Our 3 times 2 gives us a 6. And our 2 times negative, positive times negative is negative. And it gives us a 68. And we had a negative 30 up here. So now we're going to add our two equations together. Our 6's and our y's are going to cancel out. And we're going to be left with negative 14x. And this is negative 98. We have negative 14x and it equals negative 98. We're going to divide by negative 14, and when we divide by negative 14, this gives me x equals 7. Now I have to take this 7 and I have to plug it in to one of the equations to figure out what my y is. So I plug 7 in for x. That gives me, when I multiply them together, that gives me a negative 42. So I have to add 42 to the other side to get rid of that. So that gives me a positive 12. And then when I divide by negative 6, I get a negative 2. So my ordered pair is, my x-coordinate is 7, and my y is negative 2. Alright, now we're going to solve by using an equivalent system. And remember, things are equivalent. The example before in your vocabulary was $2 equals 8 quarters. So what we're going to do is we're going to underline the values to complete the sentence. To get the additive inverse for the x term, you must multiply the first equation by 5 and the second equation by negative 3. That's going to create same number, which is 15. 5 times 3 is 15, and negative 3 times 5 is negative 15. So we are going to have coefficients of a positive 15 and a negative 15. Alright, when I add these two equations together, my x terms cancel out, and I'm left with, let's see, my y terms, 35 minus 6, that is a 29y, and 75 plus 12 is 87, so it equals 87, so I need to divide by 29, and that gives me a value of y equals 3. Alright, now I'm going to take that value y equals 3, and I'm going to plug it in the first equation for y, and I'm going to solve for x. So 7 times 3 is 21. Then to get the x by itself, I have to subtract 21, so that gives me 3x equals negative 6, and I divide by 3, so my x equals negative 2. So my ordered pair for this problem is negative 2 and 3. This is your lesson check. You need to find the two systems below that are equivalent and mark out the one that is not. Here is a flowchart to help you decide what steps you should take when solving an equation using elimination. Read through this chart and follow the steps to solve an equation using a system of equations using elimination. Here's an example with a system without unique solutions. So we're looking for the solution to this system. And what is the first step? Well, look here, if you multiply that first equation by negative 1, all it does is change all the signs all the way across. We cannot eliminate a variable by multiplying it by negative 1, but if you multiply it by 2, we create this system, this equation down here. So this is what we need to do. Alright, now after we've multiplied that first equation by 2, our x's have same sign, different signs, same number, so they cancel out. And look here, so do our y's. So I'm left with 0 over here, and 0, and when I add these two over here, gets negative 4. 0 does not equal negative 4. So this system has no solutions because this is a false statement. Alright, one last example we're going to go. We're looking for the solution to this system of equations here. So our first step is to decide what to multiply one of the equations or both the equations for. And if you look, you can multiply this first one by a negative 3, and if we multiply it by a negative 3, we're going to create same sign, different sign, same number here with our y's. And that's actually also going to happen with our x's. So our first step is to multiply equation 1 by 3. When I do that, when I multiply that, actually I'm multiplying it by negative 3. I get a negative 12x minus 3y equals negative 18. And when I take the second equation and I add those two together, I am adding these two together. My x's cancel out, my y's cancel out, my 18 cancels out. So I'm left with nothing on the left side, nothing on the right side. So this is an identity. When I get a true statement here, instead of no solution, it means that I have infinite solutions. And if I have infinite solutions, the lines have to be the same. Alright, use the information on this in the video in this lesson check and see if you can explain how to solve a system of equations using elimination.